Okay, so we are talking about scientific notation. On this page, we're going to be taking numbers that are in scientific notation and putting them into the standard notation. Sometimes I call that the long form. And then on the other page, we'll be putting numbers in the regular or standard notation into scientific notation. So let's start with this one. Okay, so as it says at the beginning, when you write a number into the standard notation, the exponent tells you how many spots to move. So this is going to tell you to move 2 spots. A positive exponent, you're going to move to the right. A negative exponent, you're going to move to the left. So see how in example 1, we have a positive 2 exponent, so we move our decimal place 2 spots to the right. In example 2, we have a negative 2 exponent, so we'll move 2 spots to the left. All right? And remember, if we ever had an exponent 10 to the 0, that means you don't move your decimal place at all. 10 to the 0 is equal to 1, so you would just have the number as is. Also, remember in scientific notation, whatever number you have in the front, this number has to be between, hold on, what did I just do? Has to be between 1 and almost 10. What the heck did I just do? No, I don't want to write there. So like 1 and 9.9999. You cannot have 2 digits. All right, here we go. Express each number in the standard notation. 4.21 times 10 to the minus 3. So I'm going to start with 4.21. And I'm going to move my decimal point to the left 3 spots. So 1, 2, 3. Put my decimal place here. I think of this like an egg carton, so I have 2 empty spots. If you want to clean it up and put a 0 in the ones place, so you'd have 0.00421. The next one, 7.82 times 10 to the 2, which means you're going to move your decimal place 2 spots to the right, 1, 2, clean it up, 782, final answer. Okay, 4.222 times 10 to the minus 2. So we're going to move our decimal place 2 spots to the left, 1 and 2. Fill in my empty egg carton, so 0.04222. 8.00 times 10 to the 4th. So we have 8.00, move our decimal place 1, 2, 3, 4 spots, egg carton. So we become 80,000. Now, if you've been talking about significant figures in your class, this coefficient has 3 sig figs, whereas this number here only has 1, the 80, or sorry, that 8. So if we wanted to make sure that we maintain our sig figs, we would have to put a line over these first 2 zeros. If you and I have not talked about scientific notation, or sorry, have not talked about significant figures, don't worry about it. But in order to maintain sig figs over a 0, making a 0 significant, we would have to put that line there. It does not mean repeating. 3.999 times 10 to the minus 1 means we move our decimal place 1 spot, and so we have 0.3999. You notice I keep adding a 0 in the ones place? That's just to show, definitely that we have a decimal, it's less than 1, because sometimes maybe my decimal place isn't very large, or it's kind of like I did it quick, and maybe people don't notice, and they think it was 3,999, and it is definitely not. 1.05 times 10 to the 2, 1, 2 spots to the right, clean it up to 105. 4.172 times 10 to the minus 4, that's to the left, 1, 2, 3, 4 spots, 1, 2, 3. So to clean it up, 0.304172. Small number. 5.26 times 10 to the third, 1, 2, 3 spots to the left, to the right. Fill in that 0, 5,260. 2.045 times 10 to the 4th, which means we move 1, 2, 3, and then an additional. So we clean it up to get 20,450. 1.23 times 10 to the minus 5 means it's going to be a small number, so we're moving to the left. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, 1, 2, 3. 7.4 times 10 to the minus 1 means move to the left, and you get 0.74. Notice I added the leading 0. 8.290 times 10 to the 4th, moving to the right. 1, 2, 3, 4, 82,900. Add that additional 0. 3.1 times 10 to the minus 3 means we're moving to the left. 1, 2, 3. So cleaning that up, we have 0.0031. Finally, we have 9.7 times 10 to the 0. So that means 9.7, I'm going to move my decimal place 0 spots. We also talked about at the top how 10 to the 0 is equal to 1. So 9.7 times 1 is the same, 9.7. All right, so now with these, we have a number in the standard notation, and we're putting them into scientific notation. So remember, if you have a number that is larger than 1, we're going to be moving the decimal place. Well, first of all, in either case, we're moving the decimal place, and so you have a coefficient between 1 and almost 10. Only one digit in the ones place. And so if you have a number that's greater than 1, we're going to have a positive exponent, such as this one. If we have a number less than 1, we're going to have a negative exponent. 0.526, excuse me. So moving my decimal place one spot to the right gives me a number in scientific notation. So that coefficient is between 1 and almost 10, one digit, the 5 in the ones place. I moved my decimal place to one spot, but seeing as it's less than 1, it's 10 to the minus 1. 67,200. So I'm going to move my decimal place 1, 2, 3, 4 to get 6.7200. Now, again, like I said, oh, no, I would not include those zeros, sig figs. If we don't talk about sig figs in your class, then you can ignore that. But, you know, we do need to maintain sig figs for everybody else. Times, we move the decimal place 1, 2, 3, 4 spots, and the number is bigger than 1, so, whoops. So it's a positive exponent. You can't just say times to the 4th. It's 10 to the 4th. That's different. So we're going to go 1, 2 spots, 4.18 times 10 to the 2. No, it's 10 to the minus 2 because our number is less than 1. This number is larger than 1, so we're going to have a positive exponent. 1, 2, 8.56 times 10 to the second, or 10 squared. Number 9. Oh, no, we're going odds, evens. Okay. So this number is less than 1, so we're going to have a negative exponent. 1, 2, 3. You keep moving until you get that number to be a digit, one digit in the ones place. 2 times 10 to the third. Now remember, you really shouldn't do 2.0 because that's additional significant figures. But down here, number 11, 1, 2, 3, 4. This will be 7.0 times 10 to the 4th. However, negative 4th because it's a number less than 1. This is a number larger than 1, so we're going to have a positive exponent. So we're going to go 1, 2, 3, 3.85 times 10 to the third. Over here, I just know it's going to be 7. And I also know it's going to be negative. 1, 2, 3, 4, 5, 6, 7. 10 to the negative 7. This is going to be a positive exponent. 1, 2, 3.15. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1.2345 times 10 to the 4th. Positive exponent because we have a number larger than 1. This number is less than 1, so it's going to be negative. Only 1, 9.99. If I'm going too fast or you have additional questions, please make sure you're going to say something in class. We can talk about it. This is a positive exponent. 1, 2, 3, 4, 5, 6, 7.24 times 10 to the 6th. Negative exponent because we're less than 1. 1, 2. 2 times 10 to the minus 2. And this is a number less than 1, so it's going to be negative. And we're just going to be 9 times 10 to the minus 1 because I only moved one spot. Like I said, if you still have questions or I went too fast and you need more explanation, please reach out in class. Otherwise, thanks for watching.